For this example, what we're going to do is solve this linear system. So what does that mean? Well, we're going to find an x and a y that makes both of these equations, the one on the top and the one on the bottom, true. And we're going to look at three different methods to do this. So the first one will be substitution, the second one will be elimination, and the last thing we'll look at is something called Gaussian elimination. Okay, so remember for substitution, our goal is to solve for one of the variables and input it into the other equation. So what we're going to do is use the second equation and solve it for y. Then we're going to take this y and plug it in to the first equation. Now we can just use simple algebra to solve for x. Once we found x, we can plug it back in to our second equation to find y. So here's our final answer. Y equals 1 and x equals 4. For elimination, our goal is to eliminate all but one variable from the first equation and eliminate all but one variable from the second equation. And we're going to achieve this by adding some constant to our equations and adding and subtracting our equations from each other. We can do this because the left side of the equation equals the right side of the equation, and also line 1 is equal to line 2. My goal here is to remove the x variable from the second equation. So what I'm going to do is multiply the top line by 3 and the bottom line by -2. Then if I add the first equation to my second equation, you'll see how my x ends up going away or canceling out. I'm going to simplify even further by dividing the second line by -6. Now that I know what y is, I could use substitution and plug it into my top equation. However, we're using elimination here. So what I'm going to do is I'm going to try to use my bottom equation and try to cancel out the y in the top equation. So what I have to do here is multiply my bottom equation by -12 and then add it to my top equation. To simplify even further, I'll divide the first line by 6. Now we only have one variable in the first line and only one variable in the bottom line. And it reads that x equals 4 and y equals 1. One thing you should notice is that we have our variables in a diagonal across our screen, while everything else on the left-hand side of the equal sign is 0. Remember this because it's analogous to Gauss Jordan elimination. Now, Gauss Jordan elimination is the same as normal elimination. The only difference is that we use an augmented matrix this time. However, our method for isolating variables are exactly the same. We multiply by constants and add equations to each other. In this case, we'll be multiplying rows by constants and we'll be adding rows to each other. Notice how our result is analogous to the previous result. Elimination and Gauss Jordan elimination are the same process, except one is written in normal algebraic notation and the other one is written in matrix form. Also, notice how we have variables on our diagonal for our algebraic form, and we have ones on a diagonal for our matrix form, while everything else is 0 on the left-hand side of the equation. This further suggests the similarities between elimination and Gauss Jordan elimination.